It's a video on intro to equations. Vedic math way, we would use sutra, transpose and apply to solve simple equations, simple linear equations. Okay, it's a video number 5, W5, video, fifth video for a one-day workshop. Let's continue. Look what equations are. What's an equation? Equation represents equality or equivalency between two quantities separated by an equal sign. Equation has left side and right side, and in the middle there's equal sign. Equal sign implies that the two sides, left and right, are in balance. Okay, let's continue here. Where do equations come from? Equations arise from all sort of real and imaginary situations. Some of the examples are, here are some physical laws. Force is equal to mass times acceleration. That's Newton's law of gravity. Okay? And energy is equal to half mc squared. That's Einstein's theory of relativity. There's some identities also given by the equation, where a plus b squared, square of a plus b is equal to a squared plus b squared plus 2ab. Okay, we use these equation identities to evaluate the left side in terms of the right side. Let us continue here. Now, another way to think of a problem is think of a number. Okay, here's the game. I'm thinking of a number. I subtract 20 from it and add 15 to the result. My answer is now 48. What number am I thinking of? Okay, we solve such a problems by reversal method. Okay, what is that reversal method I'm talking about? So we take such problems by reversal method. Let's see what that is. What's the reversal method? And here is the example. To return home from the mall, we follow exactly the same path as we followed to go to the mall. But we do that in the reverse order. So that's a reversal. And change all right turns to the left turns and left turns to the right turn. That means that all additions become subtractions and all subtractions become additions. Let's continue. To apply the method, we first subtract 15. 15 is the last thing we did. We added 15. So we're going to start backward. We have 48. And we got 48 by adding 15 to something. We subtract 15 from 48. Okay, okay, from that will get me 33. Then 33 we got by subtracting from something, 20. So we add 20 back. Second, we add 20 to this 33 to get me a 53. So let's do some exercises here. Question 1. I'm thinking of a number. I multiply by 2, add 7, and divide by 3. Now I have 9. What number am I thinking of? Okay. Here, if you look at turns here, I multiply by 2. So let's say multiply is left turn. So when we come back on the reversal method, we would be dividing by. Here's add 7. So let's say this is add 7. When we come back, equivalently, we would do subtract 7 and divide by 3. In the end, we have, so we would multiply by 3. Okay, let's continue in the reversal method. So we'll take a 9 here, multiply by 3, then subtract 7 and divide by 2. Let's continue here. Here's an example. Question is, I'm thinking of number. To that I add 1, divide by 2, multiply by 3 and subtract 6. Now I have 9. What number am I thinking of? So use the reversal method to some equation here. Wish to solve such a problem, we represent that by an equation. So the equation, okay, and let x be the number I'm thinking of, and we say that we subtract 20 and add 15 become 33. Okay, so x, first we say we subtract 20, so x minus 20. I just put in a parenthesis here to indicate my order. This is I did x minus 20, and to make sure that we understand, it's clear that to that result of this thing is we're going to add 15 plus 15. Okay? So this is the equation I was thinking of. Equation has two sides separated by equal signs. So there's equal sign here, there's something on the left and something on the right. The sign indicates equality or balance between two sides. Does that remind you of a story of two cats fighting over sharing a bread and monkey with a balance to help them break the bread into two equal pieces? Let me recite the story the best I recall. The two cats were fighting over a bread they want to share equally, and they were fighting over. They went to a monkey. Monkey had a balance, which is balancing scale, and so monkey agreed to help these two little kids divide the bread into two equal pieces. So he divided the bread in two and put them on a scale. One side was heavier, so he grabbed a piece of from the bite from the heavier side, and now the other side is heavier. Now he grabbed another piece and ate that too, and finally he went on to this exercise of trying to balance the two pieces, and in the end he ate whole of the bread, and the pieces were all balanced now. His scale was balanced. So he tells, dear cats, so now scales are balanced. Both sides have equal number bread, and you can the cat on left can have the bread from the left pan, and the cat on the right can have bread on the right pan, and there was nothing in the pans anyway. Let's continue. Okay, in dealing with the equation, we maintain that balance or integrity of the equation. So when we're doing equations here, we solving equations. Solution solution of such equation involves moving all constants to the right, keeping only 1 times x on the left. So anything on the right is answer to x equals, okay? Because 1 times x is same thing as x. Let's continue. Solution for x is the right hand side, okay? Observation, in the above equation we had x minus 20 in parentheses plus 15 equals 33. Highest flag value, which is power of the variable x of any term, was 1, okay? And a constant term has a flag value of 0. Such equations are linear equations, okay? So in this video we'll consider only linear equations. Let's see how to solve the equation now, okay? To solve the equation, we apply a sutra, transpose and apply. So we are trying to transpose everything that doesn't have the variable to the right, okay? Let's continue here. When we move added term across equal sign, it gets transposed to a subtracted term. So this is my transpose here, get transposed to. If we move a added term across equal sign, it gets transposed to a subtracted term. Let's continue. When you move a subtracted term across an equal sign, it gets transposed to an added term. So this is transpose here, sutra, transpose and apply. So subtracted term gets transposed to an added term. Let's continue here. When we move a multiplied by term across equal sign, it gets transposed to divided by term. It gets transposed to divided by term. Let's continue here. When we move divided by term across equal sign, it gets transposed to multiply by term. Transposed. So these are the sutras for transpose and apply as we get applied to solving equations, linear equation. Let's say when you move an added term across becomes subtracted term. When you move subtracted term becomes added term. When you move multiplied by term, it becomes divided by term. When we move divided by term, it becomes multiplied. Let's continue and solve a equation. Let's do example here. We have been talking so far about x minus 20. After we do x, first we do x minus 20, then to that add 15, and result is 33. X is the number I'm thinking of. To that I subtract 20 from that. Whatsoever result is, that tells me this parenthesis here saying I'm going to do x minus 20 first. Whatsoever we got, to that we get plus, add 15 to that, and answer is 33. Let's continue here. How do you solve it? So this is the last thing we did. So we're going to subtract, we're going to move that across the equal sign, and this is added term, it becomes subtracted term. So which move plus 15 from left, which get transposed to negative 15 on right. Let's continue here. Now it's a minus 20 left is here. Okay, first of our right side is 33 minus 15, which is 38. Okay, and now on the left I have minus 20, which I need to move to the right. Let's continue here. So we have, so far we have x minus 20 equal 33 minus 15, which is 18. Okay, and now parentheses, I don't really need parentheses here anymore because I have x minus 20, the first operation I did. Let's do the x. Let's continue here. Some folks would subtract 15 from both sides to cancel out 15 on left. In VM, we use the sutra and skip that extra step. Okay, so you could have subtracted 15 from both sides with cancelling out the 15 on the left, and would have 33 minus 15 on the right. But we'll use the sutra that added terms get transposed to subtracted term when we move to the right, move across the equal sign. Let's continue here. So now I'm going to move this negative 20 to the right, which is going to become positive 20. So the subtracted term minus 20 get transposed to added term plus 20 when we move that across the equal sign. Let's continue. So on the right side I have 18 plus 20, which is 38. So and on left I have x left. So x is 38. Let's continue here. So x is equal to 18 plus 20. I just wrote that, and x is 38. Okay. I do go through a number of steps here, and with practice you would start to combine steps. Okay, let's do some examples here. X equals 6 plus 3, no transpose required. Everything that's constant is on the right side. 6 plus 3 on the right is 9, so x is 9, which just we solved that by observation. Let's continue, and this example requires 0 transpose. We did not have to transpose anything across the equal sign. Let's continue here. Here's another example. X plus 3 is 9. 3 is on the plus 3 is on the left, and we need only x on the left. So this thing has to be transposed to the right, and added term becomes a subtracted term. Let's continue here. So we just move that plus 3 to the right and becomes a minus 3. Okay, 9 minus 3 is a 6. So x is a 6, the answer. So x is 9 minus 3, extra step here, and x is a 6. That's the answer here. Let's continue. So this example requires 1 transpose. We transpose plus 3 to the right, which become a minus 3. Let's continue here. Example is 2 times x equals 7. So we had x, a number I'm thinking of, multiply by 2, and the answer is 7. Let's continue here. So I'm going to move that, transpose the 2 times from left, which become divided by 2. Okay, so it's a multiplied by term here, become divided by when I go to the right. Let's continue here. So x is 7 by 2. That's the answer. Let's continue. How many transpose was this required? This had only, we transpose multiply by 2 to the right as 1 transpose was. Okay, so x minus 3 is 13. Minus 3 is something we need to get that on the right, which means transpose. That means negative term, subtracted term get transposed to across the equal sign, become plus 3. So let's see what happens. We take a minus 3 here, and which become a added term plus 3 on the right. Continue. So x is 13 plus 3, 13 plus 3, which is 16. Okay, so again x, let's do another example. X divided by 3 is 7. So divided by 3 is, other than we only need x here, divided by 3, we got to go to right, which means move that across the equal sign. Then we get transposed to multiplied by term. Okay, let's continue here. So this divided by 3 get transposed to the right and become multiplied by 3. Let's continue here. So x is equal to 7 times 3, which is 21. So we have some example where we require two transposes here. So first we had x, we multiplied by 2, whatsoever that was, we added 6 to that, and answer is 13. So first this plus 6 goes to the right, we move that across equal sign and get transposed to minus 6. Let's see what happened. So we move that and become minus 6 here. Okay. So we have, so far we had 2x equals 13 minus 6, 13 minus 6, which is equal to 7. Okay. So now I got to move this multiply by term, multiply by 2 to the right across the equal sign right here. That become divided by 2. Let's continue here. So that means x is 7 by 2. Let's continue. X, here's another one, x divided by 3 plus 1 is 4. So move that plus 1 to the right, which means added term get transposed to subtracted term when we move across the equal sign. Let's continue here. So this one disappear, we move that right, become minus 1. Now we have x divided by 3 is equal to 4 minus 1, which is 3. Okay, let's continue here. So now divided by 3 get transposed to multiplied by 3 when we transpose across equal sign. So on the right side we have a 3 times 3, 9. Okay. So x is equal to 3 times 3, which is equal to 9. Let's continue. So x is 9. And let's do 3 times x minus 41 equals 13. Let's continue. So first we transpose negative 41 to the right, we become positive 41. 13 plus 41 is 54. Let's continue here. That means 3x is 54. Now 3 multiplied by 3, we transpose that to right, become a divided by 3. Let's continue. So we divide by 3, and 54 divided by 3 is 18. That means x is 54 divided by 3, which is 18. Let's do some examples here. So first we add 1 to x, then so that comes up to, we multiply that by 10. Results of that, we add 5 to that, okay? So this plus 5 is the last thing we did. We're going to move that across the equal sign, become minus 5. Let's continue here. Okay? So we get 115 minus 5 on the right. Okay? And this 5 got transposed to the right and become minus 1. Let's continue here. So that means x plus 1, which this side times 10 is 110. Okay, let's continue. Now this 10 here multiplied by 10 become divided by 10 on the right. We move that multiplied by 10 across the equal sign and become divided by 10. Okay, let's continue here. That means x plus 1 right here is 110, that one divided by 10, which is 11. Let's continue. Then we move the added 1 across the equal sign, become minus 1. Okay, let's continue here. That means x is 11 minus 1, which is equal to 10. So x is equal to 10. Let's continue. So, okay, let's do another example here. X minus 1 times 2 minus 3 equals 5. Okay, that means that this is the last operation we did on x and minus 3. But we move that across the equal sign and we become subtracted term becomes added term on the right. Let's continue. So we just move that to the right, become added term plus 3. 5 plus 3 on the right is 8. Let's continue here. That means on the left we have x1 minus 1 times 2, and on the right we have 8. Let's continue. Now we have to do this multiplied by 2. We're going to move that across the equal sign, which would become divided by 2. Let's continue here. Okay, so we move that plus divided multiplied by 2 to the right, become divided by 2. 8 divided by 2 is a 4. So on the right side we have 4. Okay, then we x minus 1 on the left equals 8 by 2, which is 4. Let's continue. And now this minus 1, when we transpose that to the right, become plus 1. So minus 1, when we move that to the right across the equal sign, become plus 1. That's it. Subtracted term get transposed to added term. So we have x is equal to 4 plus 1. This is 4 plus 1, and which is equal to 5. do more transposes here. Here is x minus 1. First we do subtract 1 from x, then multiply the result by 3 and add 2 to the result of multiplication by 3 and get result is 26. Let's continue here. Okay. First we do is this added, we added plus 2 last, we subtract that, we move that to the right and across the equal sign the added term become a subtracted term. 26 minus 2 is 24. On the right we have a 24. Let's continue here. So we have x minus 1 times 3 equals 26 minus 2, 26 minus 2, which is 24. Let's continue here. Now this multiplied by 3, we got to move that across the equal sign and we become a divided by 3. Let's continue here. So multiplied by 3 became divided by 3. Okay? 24 by 3 is a number on the right, which is 8. Let's continue here. So that means x minus 1 equals 24 by 3, which is 8. That's what we have on the right side. So that now this minus 1, we move that across the equal sign and become a plus 1. Subtracted term, when we move across the equal sign, become added term. Let's continue. So minus 1 become plus 1. Okay? Continue here. So we have x is equal to 8 plus 1, which is 9. So x is 9. Let's continue. And let's another example here. 2x plus 3 times 2 minus 6 is 8. Let's continue here. So first is last thing we did, subtracted 6. Now we move that minus subtracted term to the right, become added term. Plus 6. Okay. Now so on the right we have 8 plus 6 is 14. Now it's multiplied by 2 here, and that when we move that across the equal sign, we become a divided by 2. Let's continue here. So move that multiplied by 2 become a divided by 2 on the right side. So 14 divided by 2 is a 7. So on the right we have a 7. So we have on the left we have 2x plus 3. On the right we have a 7. Let's continue. Now this plus 3 is first we do 2 times x, then to that we add plus 3. So now we have to move this plus 3 to the right, and when we move across the equal sign, that get transposed to minus 3. Let's continue. So this we get this move with the plus 3 and become minus 3 on the right. 7 minus 3, which is 4. That's what we have on the right. Okay, let's continue here. So that means 2x is 4. Okay, and now this multiplied by 2 terms, we move that across the equal sign, become divided by 2. Let's continue. So now we move that multiplied by 2 to the right across equal sign, become divided by 2. Okay, so 4 divided by 2 is a 2. So that means on the right we have a 2 so far. So that means x is 4 by 2 equal, which is. Let's do some more examples. Here's an example. First we multiply x by 2. From that we subtract 1. And result so far we multiplied that by 4. To that we add 2. Then results of that we divided by 3. And answer is 10. Okay. First we would move that divided by 3 is last thing we did. We would move that across the equal sign, become multiplied by 3. Let's continue here. So right on the right we have 10 times 3, which is 30. Let's continue. So far we have 2x minus 1, and which result of that is multiplied by 4 plus 2 and equals 30 on the right. Let's continue. Now this plus 2 is the on the left side, plus 2 is the last thing we did. So we move that across the equal sign, and added term becomes subtracted term, and it become a minus 2 on the right. Let's continue here. So on the right we have 30 minus 2, which is 28. Okay, let's continue here. So we have 2x minus 1 times 4. On the right we have a 28. Let's continue here. Now as multiplied by 4 is the last thing we did on the left side. We would move that across the equal sign and become divided by 4. Let's continue here. So multiply by 4 become divided by 4. So 28 divided by 4 is 7 on the right. Let's continue here. So we have a 2x minus 1, which is a 7. Let's continue. Now this minus 1, we would transpose that across the equal sign and will become a plus 1. Okay. So we just move that. Okay, let's continue. So the 2x plus 1 is 2x minus 1 is 7. Okay, let's see what happened. Then we move that, we come plus 1 here. 2x minus 1 was 7. We transpose the minus 1 to the right, become plus 1. 7 plus 1 is 8. Let's continue here. That means 2x is 8. That means x is 8 by 2, which is 4. Let's continue. So x is 4. Let's continue. Let's look at some exercises here. Solve for x in the following. Okay. Here is a x minus 4 in parentheses minus 3 plus 0 is 80. Okay. Let's continue here. X minus 5 in parentheses plus 1 in parentheses minus 4 equals 42. Okay. First we subtract 4 minus from x, then to the result of that we add 5. To result of that we subtract 3, and that is equal to 77. Let's continue here. So here is 2x plus 3 minus 1 is 8. Let's continue here. And 3x plus 4, we multiply that by 10 plus 5 multiplied, add to that we add 6, and result is 3, 4, 5, 6. Let's continue here. Okay, it's 7x minus 6, multiply that by 10 minus 3. Result of that, we multiply that by 10 plus 9 and equals 6379. Let's continue here. X plus 3, that result of x plus 3 multiplied by 2. From that result, we subtract 7. And to that result so far, we multiply by 3. And to that, we add 2 and equals 29. Let's continue here. 2x plus 4, result of that we multiplied by 5. From that we subtract minus 3, and result of that we multiplied by 4 plus 1 is 269. Okay? And for more example, you can look at Glover's book 1. All the ideas presented here are from that book. If you look at Khan's Academy, you can start from here. I give you the links. Their links are valid at the time I wrote them up, and the sites keep changing links, so as such you have to look around, and maybe there's different link when you are looking around. I hope the link does not change, but that's the link when I did it. Let's continue. Let's look at references now. First reference is Vedic Math Teachers Manual, Elementary Level, which is by Ken Williams, and you can purchase that in print form or get free in the PDF form from vedicmaths.org. Okay, just look around and you'll find it. Hindi edition is also available in PDF form. Vedic Mathematics by Bharti Krishna Tirthaji is the main reference. Okay? And I use that Vedic Math for Schools in 3 volumes by James T. Glover. Mr. Glover uses 3 books in this school, and for this video I use the volume 1 of this Glover's book. Okay? Vedic Math for RAGs by Vanna Singhal is a decent and readable text. Let us continue here.